Hey, what's up? It's your main man, Coach Hyde here, talking about some isotopes, right? Isotope. Okay. This is different versions of the same element. So different versions of carbon, different versions of hydrogen, different versions of whatever. Meaning it's still carbon, still hydrogen, but it's different. It might be heavier or lighter or something like that. So we're going to focus on carbon and use carbon to explain the situation. So as we looked at last time, this is what we see on the periodic table for carbon. We know the atomic number tells us the amount of protons, right? We know that this tells us the mass, which is the combined amount of things in the nucleus, which is protons and neutrons. So we can kind of look at this by now, hopefully, and say, okay, well, this has, there are 6 protons. 1, 2, 3, 4, 5, 6. If there are 6 positives, then we want a balanced atom. We need 1, 2, 3, 4, 5, 6 negatives to balance it out. So there's 6 positives, 6 protons, 6 negative electrons, and because the mass is 12, right, we can do 12 minus 6 equals 6. There are 6 neutrons. This is just our normal basic atom, right? We could call this version of carbon, carbon 12. So it's like adding the last name. Like, my name's not really Coach Hyde, all right? My name is Perry Hyde. First name, last name. 2 names to describe me. First name, last name. This is not just carbon. This is carbon 12. All right, so this is how we can really write the name. These are the exact same things. Carbon and carbon 12 mean the same thing, right? We're just kind of throwing that mass on there. There's other ways we could write this as well. We can write our symbol, right? In this spot right up here, we can write the mass. So we can write this carbon 12 like that. So we just throw the mass up there, right? Nothing different. Still the same thing. Just adding a little more information on it. We could also write this, right? We could put, guess what, right there. What are we missing? We got the mass, atomic number. We could throw the atomic number in there. We're going to throw it in there on the bottom. So these are all the ways we can write the same carbon, all right? What if this was a fat carbon, right? Like the Coach Hyde version of carbon, right? A little heavy. Let's put 2 more neutrons in there. So, did this change the atomic number? The atomic number is the number of protons. 1, 2, 3, 4, 5, 6. Okay? So the number of protons is still 6. So that means it is still carbon. If that had changed, no carbon, right? So if we would have added 1 or took away 1, no carbon. It would have went. If we added 1, it went to nitrogen. Took away 1, it went to boron. Did it change our balance positive negative situation? Well, I had 6 positives still. 1, 2, 3, 4, 5, 6. Still got 6 negative. Still balanced. Nothing's changed. So, as of right now, I still got 6 protons. I still got 6 electrons. But now I got 1, 2, 3, 4, 5, 6, 7, 8 neutrons. Okay? Look. Okay? Different amounts of neutrons. Before I had 6, I added 2, right? I'm the magical isotope god. I added 2 neutrons to it. So this does no longer have a mass of 12. Now I have a mass of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, I have a mass of 14. So this is not carbon 12. This is a cousin or a isotope. Right? Use our word here, isotope. So we're going to write this a little different. It's still carbon. All right, still carbon. Now it's carbon 14. Right? Before the carbon had a mass of 12. Now the carbon has a mass of 14 because there's 2 extra neutrons. So we write it this way. This is how we know which one we're dealing with. I could also write it 14 like that. Or I could also write it like that. Notice the proton number is the same on both. So this and this are isotopes. They are isotopes of carbon. They are the exact same element, carbon, but they're 2 different versions of that. One is skinny carbon. The other is fat carbon, right? Heavier, more mass. So this number means the mass. Anytime you see this number, so if you come across carbon-14, you can still use the periodic table exactly the same way you always have, except this is no longer 12.01, it'll be 14. Right? That's only when you see the isotope version of it. That's isotopes of carbon. Peace out.